All right. Hi guys. Good evening. कितने participants join कर लिए हैं? ठीक है. Good. I think we have good number of students. Great. So today we are going to discuss or start with atomic structure chapter, right? And I hope you were aware of this. This is not coming as a surprise to you because this is something that we discussed in the beginning of this week itself. Now, in terms of preparation, yes, I would recommend that those who are continuing with mole concept, should not just start randomly in between the chapter in their notes. आप अलग से एक notes copy बना लो for this chapter and mole concept वाली book में mix मत करो. It will be something of a problem for you, or if you can manage, then it is up to you. Right now, आज का लेक्चर विल नॉट बी समथिंग जिसमें हम लोग काफी डेप्थ में जाएंगे. आई एम जस्ट गोइंग टू गिव यू एन इंट्रोडक्शन टू द चैप्टर इटसेल्फ एंड this is something which will be or which can be a repetition for many students who have actually done atomic structure chapter in their previous batches. So it's an optional session for all those students. They can choose to stay or they can choose to opt out. Now, let me share the screen. All right. So, from an exam perspective, it is a very important chapter. इसका weightage chemistry as well as physics दोनों में रहता है. Chemistry में it is in fact a starting chapter, first or second chapter in your course, whereas in physics you will study this chapter towards the end of your 12th class. एक chapter आएगा modern physics करके and काफी overlapping content रहेगा. ठीक है. So आप लोग अभी पढ़ोगे तो एक बार 12th क्लास में जब आप फिजिक्स में आओगे तो उसका एक क्विक ब्रश अप आपको डेफिनेटली मिलेगा. नाउ एज आई सेड, एग्जाम के पर्सपेक्टिव से इंपॉर्टेंट इसलिए जाता है बिकॉज एवरी ईयर इन केमिस्ट्री एज वेल एज फिजिक्स सेक्शन देयर आर क्वेश्चंस दैट आर आस्क्ड फ्रॉम दिस चैप्टर. नाउ लेट मी provide you an outline in terms of how this chapter will be. So observe karna, we will go in a chronological order. ठीक है? When I say chronological order, हम लोग in the order of how things got discovered, how different theories and models came in that manner that we are going to approach this chapter. So introductory part में हम लोग starting में subatomic particles का discussion करेंगे. ठीक है? Subatomic particles and their discovery, electrons, protons, न्यूट्रॉन पे ज़्यादा फोकस नहीं रहेगा, बट थोड़ा सा उसके बारे में बात करेंगे. Then we'll talk about different models of atoms that came in. Now when we talk about the different models, तो इसमें आप लोगों ने जूनियर क्लासेस में ऑलरेडी पढ़े हुए हैं. There is J.J. Thomson model that is followed by the gold foil scattering experiment. Gold foil experiment plus इसके एडिशन में रदरफोर्ड्स मॉडल आ जाता है. Then before we get into Bohr's model of atom, I generally take a detour and हम लोग as part of our continuity we'll talk about theory of light, both the wave nature as well as particle nature. Quantum theory हम लोग इसको बोलेंगे. इसमें हम लोग कुछ important experiments भी पढ़ेंगे, like photoelectric effect. And then इसके बाद में we'll talk about Bohr's model of atom. Now this is something यहाँ तक आप लोगों ने ठीक है जूनियर क्लासेस में पढ़ा हुआ होगा. Maybe not the theory of light, that is something which will be a little different. Then once that is done, we will talk about the next evolution that happened in the structure of atom. ठीक है? बोर्स मॉडल ऑफ एटम ये आप लोगों ने यहाँ तक जूनियर क्लास में पढ़ा होगा. इसके बाद हम लोगों का एक डिफरेंट पर्सपेक्टिव आएगा. वी विल बी टेकिंग अ लुक इनटू द क्वांटम मैकेनिकल वर्ल्ड. ठीक है? एंड यहाँ पर देयर विल बी डी ब्रॉगलीज हाइपोथेसिस, हाइजेनबर्ग्स अनसर्टेनिटी प्रिंसिपल एंड देन क्वांटम मैकेनिकल मॉडल. ठीक है? क्वांटम मैकेनिकल मॉडल will be something which will be a big focus in this chapter. Okay, so we will understand that based on our progress, how we are going ahead in this chapter. So uske pehle bhi there are quite a few important subtopics which will come our way, and this is all going to happen in a chronological order. As I said that पहले क्या theory आई, उसके बाद then what is the next theory that came in and how this evolution took place. So if you ask me in terms of a broad outline, given that we have 1.5 hours lectures, so जो old वाला part है इसमें हम लोगों को at least 6 to 7 lectures लग जाएंगे. ठीक है? उससे कम भी हो सकते हैं. I am taking it on a higher side depending upon how we progress with things. It can be यहाँ पर जो थ्योरी ऑफ लाइट है इसी के अंदर 2 लेक्चर लग जाएंगे. बोर्स मॉडल के अंदर 2 लेक्चर लग जाएंगे, एंड ये इंट्रोडक्टरी पार्ट में भी 1 लेक्चर लग जाएगा डिपेंडिंग अपॉन how our progress is. ठीक है? So maybe after a good 6 lectures, 5-6 lectures, हम लोग क्वांटम मैकेनिकल मॉडल की तरफ मूव करेंगे. ठीक है? So this was something to address one of the common doubts which is there amongst students who have completed till quantum mechanical model. They have not completed quantum mechanical model, just before that उन्होंने complete किया हुआ है. So to give you an idea, at least 6-7 lecture लग सकते हैं before we reach there. ठीक है? Now, apart from this, any other doubts? I can see Shreyansh raising his hand. Shreyansh, I'll unmute you. Let me know what's your question.
सर एक्चुअली मेरा टिल क्वांटम मैकेनिकल मॉडल तक हो गया, तो सर नोट्स अलग से बनाने की जरूरत है कि उसी में एडिशन करना है?
अगर आपका हो चुका है एंड आप रिविजन्स के लिए बैठ रहे हो, तो फिर आप जस्ट उसमें ही नया चीजें ऐड कर दो नोट्स में. आपको देखो टॉपिक तो समझ में आ ही गया है.
हाँ
तो इवन इफ आई एम टेकिंग द टॉपिक अगेन, तो ऐसा नहीं रहेगा कि आपको बिल्कुल समझ में नहीं आएगा. तो बेटर ये रहेगा कि आप अपने एग्जिस्टिंग नोट्स को ही बीफ अप करो रादर देन मेकिंग अ न्यू सेट ऑफ नोट्स.
ओके सर.
ऑलराइट, एनी अदर क्वेश्चंस? Okay, so there's a question that can you even tell how you want me make notes? Matlab, I didn't understand the question itself. Like how to make notes, is that your question? Matlab, if you are looking at an answer to this question, then I think पिछले 10 साल का या जो भी 11-12 साल का स्कूल है वो खराब हो गया तुम्हारा. नोट्स कैसे बनाते हैं? Like you are sitting in a live class, आपके सामने एक स्क्रीन पर कुछ सिखाया बताया जा रहा है एंड उस चीज को आप ऑब्जर्व करोगे, अपनी 2 आंखों से देखोगे एंड देन उसके बाद में यू कैन राइट दोज थिंग्स इन एन आर्टिकुलेट मैनर. I will be sending these class notes, so if you want then you can refer to those class notes and then beef up your existing notes. All right, so then there is another doubt from Ronan, which is, can you please send the link of WhatsApp group on WhatsApp doubt group on Pace group? मैंने भेजा है रोनन. मतलब I will resend it again if you have not joined it. I will जो official group है उसमें मैं chemistry doubts वाला group का link भेज दूंगा. Okay, then Moiz has a question that Moiz फालतू question मत पूछो please. मतलब आपको जो instruction मिला है वो follow करो. I do not know which batch you are from. If you are from an old batch, then you are supposed to give the exam. If you are not from the old batch, if you are a new joinee, then you are not supposed to give the exam. That is something that is a clear instruction that has been given. अब मुझसे पूछ के तुम वापस क्या reiterate करोगे इसको? All right, so let me take this away. Now let's start with the introductory part of this chapter. Now what I'll try to do is try to make this introductory part a little more interactive, wherein we will explore some finer details about these experiments that help discover subatomic particles. Right, so I'll start with a heading which is discovery of, in fact, for the sake of formality, I will start with, say, Dalton's theory of atom. Okay. And then I'm going to skip it, saying that this is something that you have done in your junior classes. So if you remember, there were some postulates. Just a second, I'll share the actual screen, तो ये PDF भी share होगा. So आप लोगों के पास में बुकलेट में ये डाल्टन्स थ्योरी के postulates and all रहे होंगे, जो आई एम प्रीटी श्योर दैट आप अपने स्कूल टाइम से बहुत बार पढ़ते हुए आ रहे होंगे. Now all of these postulates are now invalid, and that will be something interesting to talk about. If you can give me insights on what has contradicted these postulates. So the first one, matter is made up of indivisible particles called atoms. Right, let me start. I'll say that this postulate is now not valid because we now know that atom is made up of many smaller particles, subatomic particles. हमारे syllabus में we get into details of electrons, protons and neutrons. That will be something जहाँ पर हम लोग अपना syllabus restrict करेंगे. Now, for the sake of general knowledge, we understand that even protons and neutrons are made up of elementary particles. Okay? And there are a whole bunch of elementary particles that have been discovered by scientists over the last century. Now, as part of our syllabus, we don't get into the details of those subatomic or you can say elementary particles. The only two elementary particles that are part of our syllabus that we discuss in depth is one is electron and the other is photon. Okay? These are particles which are elementary in nature and till now have not been found to be made up of something else. They are fundamental in nature. इसके अलावा quarks, leptons, bosons ये सब नहीं पढ़ने वाले हम लोग. ठीक है? All the force particles and other details, that is not something which you are going to get into details of. ठीक है? So electron, प्रोटॉन एंड न्यूट्रॉन ये तो आप लोगों ने जूनियर क्लास में पढ़ा ही है. इसके एडिशन में जस्ट एक नया एलिमेंट्री पार्टिकल हम लोग डिस्कस करेंगे कॉल्ड फोटॉन. क्या होगा वो बाद में बताऊंगा आप लोगों को. ठीक है? All right. Now the second postulate, atoms can neither be created nor destroyed. Right? So this is something again which has been thrown out of the window because of the discovery of nuclear reactions. In case of nuclear fission and fusion, right, atoms can be broken down. Then when we talk about the third postulate, atom is the smallest particle of an element which takes part in a chemical reaction, right? So this is also something which has been violated. What we now understand is that electrons are actually the one which are primarily particles responsible for formation of bonds. जब chemical reaction होता है, atom दूसरे atom के साथ में combine करते हैं, तो it is actually the electrons that are shared or exchanged between atoms. Then the fourth postulate that talks about atoms of the same element being identical in all respect, size, shape, mass. This is also something that has been violated once isotopes were discovered, right? So same element के different atoms भी हो सकते हैं जिनका size, mass different हो सकता है, right? Atoms of different elements have different mass, shape and size. Well, maybe yeah, but you can find some isotopes जिसमें let's say किसी दूसरे दो different elements है but उनका mass is similar, if not exactly same but quite similar. So this is also something which gets contradicted through isotopes. All right, so Arpit ka question hai, how do isotopes have different atoms? Are so atoms are made up of protons, neutrons and electrons na. So for example, you have carbon 12 and carbon 14, right? So carbon 12 के अंदर 6 न्यूट्रॉन रहेंगे but carbon 14 के अंदर 8 न्यूट्रॉन रहेंगे within an atom. So this is something which will be different. Now when we talk about atoms of different elements, combine in a fixed ratio. So ye actually again that ratio goes for a toss if you take into isotopes into account. So ye sub postulates, right, actually are no more valid. They are something which were given by Dalton long back, like 1800 ke starting era mein, and nothing much was actually spoken about the atom, and nothing much was being researched at that point in time to get into the details of atom. Us time actually one of the most interesting areas of research was electricity and magnetism. जिस टाइम की ये बात हो रही है 1800 समथिंग के बारे में. So around that time, during ये आप देखोगे यहाँ पर 1850s also, like the scientists at that point in time, they did certain experiments, and those experiments were also not done with the intent to study about atoms. They were done with the intent to study about electricity. But it was accidental discovery that led to discovery of or that led to discovery of these subatomic particles. तो उसमें हम लोग एक पहले केस के बारे में बात करेंगे जहां पर हम लोग इलेक्ट्रॉन का डिस्कवरी का स्टोरी देखेंगे. ठीक है, सो यहाँ पर आप ऑब्जर्व करना. लेट मी स्टार्ट विद द नेक्स्ट टॉपिक. एज आई सेड, डिस्कवरी ऑफ सबएटॉमिक पार्टिकल्स. नाउ इन दिस हम लोग, एज आई सेड, पहले इलेक्ट्रॉन का डिस्कशन करेंगे. देन आई विल ऑल्सो गिव यू एन आइडिया अबाउट प्रोटॉन्स एज वेल. ठीक है. अक्षय, मेरी तरफ से वॉल्यूम का कोई कंट्रोल नहीं है. मतलब there is this microphone and I am sitting as close to the speaker as it is possible, so it is not me who can increase the volume. You will have to increase the volume from your side or use earphones maybe. All right, so let's talk about the cathode ray tube experiment. So as I said, यहाँ पर आप observe करना. Now in this, let me give you the setup. This is also something that you would have seen many a times in your junior classes. So there is this glass tube. Okay. In fact, actually before going into the setup itself, let me show you the experiment itself. Now I am going to play this video here. I am not sure if this is something which you will be able to clearly see with lag, but let's give it a try. Okay. I am going to play this video. Okay. आप लोगों को लैग आ रहा है तो मुझे बताना. देन आई विल शेयर द लिंक विद यू ऑन द चैट सो यू कैन क्लिक ऑन दैट लिंक एज वेल. सो दिस इज द सेटअप ऑफ अ कैथोड रे ट्यूब एक्सपेरिमेंट. ठीक है, ये पोटेंशियल डिफरेंस अप्लाई करने के लिए एक सोर्स लगाया हुआ है एंड द सेटअप इज स्विच्ड ऑन and what we find inside that tube is something interesting. This is something which is what scientists at that point in time were quite curious about, that in this setup there were these glows that were coming. There were these strange glows. Earlier there is some pink glow, then there is some green glow that was being seen, and that kind of aroused the curiosity of the scientists at that point in time, right? So if you were not able to, हाँ हो सकता है lag आ रहा हो. So let me do this thing. Let me copy the link and let me share it on the group as well. So just give me 1 minute. All right, so ये link सबको मिला, एक बार देख लो. Can you click on the link? All right, great. So open this link and it's a very short link only. एक 2 minute का ही video है और roughly around 1 minute 12 seconds. Look at the video and then I will go into the explanation bit. Ha, Shreyans, you wanted to Say something, Shreyash. मैं आपको अनम्यूट क्यों नहीं कर पा रहा हूँ? हाँ, वो अजान बज रही है इसलिए वो बैकग्राउंड में म्यूजिक आ रहा है. वो अजान 5 मिनट में खत्म होगी, फिर वो म्यूजिक बंद होगा. It is very humble of you to call it music. All right. So yeah, I think most of you have seen the video. Now, let me talk about that cathode ray tube experiment. Right. So what you saw in front of you is an actual experiment. It is not an animation. It is not something which is a simulation of sorts. It is an actual experiment that was done, and the observation was something that was quite interesting. Now I'm sure that you guys have a lot of doubts. ठीक है, आपके डाउट्स की कोई लिमिट ही नहीं है. आप लोग चैट पे मुझे ऑलरेडी भेजना शुरू कर चुके हो सिंस द बिगिनिंग इटसेल्फ. why pink color, why green color, why the color. ठीक है, आई एम श्योर ऑल दोज डाउट्स आर देयर. ठीक है, वी विल एड्रेस देम. ठीक है, तो अब मेरी बात ध्यान से सुनना. लेट मी फर्स्ट एक्सप्लेन इट टू यू पेशेंटली. ठीक है, आप अपने डाउट्स को कहीं पे लिख के रखो. हो सकता है व्हेन आई एम गोइंग टू एक्सप्लेन योर डाउट विल गेट एड्रेस्ड. ठीक है, एंड इफ इट डजंट गेट एड्रेस्ड देन आप मुझसे एक बार डिस्कस करना. ठीक है, सो अभी के लिए आई विल नॉट टेक दोज डाउट्स बिकॉज यू विल स्टार्ट आस्किंग any random question and the flow will be disrupted. ठीक है, so save your doubts for later. Let me do the explanation bit first. All right, so यहाँ पर समझना कि सेटअप कैसा था. So the setup is something in this manner, that there is a glass tube. In this glass tube there is a provision to take air out of it. ठीक है, यहाँ पर एक पंप लगाया हुआ है that sucks the air out of this glass tube. So यहाँ पर there is gas present but at very low pressure. ठीक है, then at the ends of this glass tube there are two metallic plates that have been placed, and they have been connected to a high potential difference source, roughly around 10,000 volts. ठीक है, very high. This is not something जो कि आपके घर पे जो रेगुलर स्विच होते हैं, जो आपके घर पे इलेक्ट्रिसिटी आती है, that is also in India around 220 to 40 volts. So this is a very high potential difference that has been created. Now नेगेटिव टर्मिनल के साथ जो इलेक्ट्रोड अटैच होता है उसको कैथोड बोलते हैं, एंड पॉजिटिव टर्मिनल के साथ जो इलेक्ट्रोड जो मेटल प्लेट अटैच्ड है उसको एनोड बोलते हैं. नाउ इस एक्सपेरिमेंटल सेटअप का ऑब्जेक्टिव at that point, the scientists who were working on this was to study the original objective was to study flow of electricity through gas at very low pressure. Study flow of electricity through gas at very low pressure. Now जैसा मैंने आपको बोला था कि इलेक्ट्रिसिटी एंड मैग्नेटिज्म वो इसके पहले ही डिस्कवर हो चुके थे, एंड दैट वाज व्हाट द प्राइमरी एरिया ऑफ रिसर्च then was. So this was a part of that research that they wanted to study that gas के थ्रू कैसा इलेक्ट्रिसिटी का कंडक्शन होगा. ठीक है. Now what happened was something which was not their expectation. What happened, जो आप लोगों ने एक्चुअल एक्सपेरिमेंट अभी देखा उसमें इमेजिन करो दैट वो पिंक वाला जो आपने ग्लो देखा वो नहीं है. ठीक है. वो पिंक वाला ग्लो जो है वो बिकॉज ऑफ गैस प्रेजेंट इनसाइड आता है. दिस गैस इज एक्चुअली समथिंग which is responsible for that pink glow, and we will later talk about it. थोड़े टाइम बाद मैं इसके बारे में बात करूंगा. we'll call them anode rays. ठीक है. बट वो मैं थोड़े टाइम बाद बात करूंगा. तो अभी के लिए I will want you to forget about that pink glow. What I would want you to focus on is the green glow. Now if let's say you have extremely good vacuum pump, ठीक है. एक्चुअली पुराने जमाने में टेक्नोलॉजी इतना एडवांस नहीं था कि काफी अच्छा वैक्यूम क्रिएट हो पाए. ठीक है. जैसे एटमॉस्फेरिक प्रेशर 1 atm रहता है, तो पुराने जमाने में द टेक्नोलॉजी दैट वाज देयर उससे 10 की पावर -2 या 10 की पावर -3 atm, मतलब इतना कम तक वैक्यूम क्रिएट कर पाते थे. धीरे धीरे टेक्नोलॉजिकल एडवांसमेंट्स हुए, 10 की पावर -5 atm तक भी हम लोग लेके आ पाए प्रेशर्स. अभी तो इससे और भी नीचे हम लोग लेके आ पाते हैं. वी आर एबल टू actually create almost near vacuums inside glass tube. So let's, for the sake of our discussion, imagine that the gas is hardly present, matlab there is very very less, matlab extremely less quantity of gas that is present. So what will happen in that case is that pink glow will not come. ठीक है. Or it may come but for a very very like fraction of a second time. ठीक है. What you will be primarily seeing is the green glow. So the scientists, what they observed was a strange green glow on the glass walls, and especially behind the anode. So this is something that was a peculiar observation. Green glow on glass wall behind anode. Now the scientists wanted to study more. They were quite intrigued by this green glow, that ये glow आया कैसे, like how come this green glow is present there. Now, in order to study more about this green glow, they actually did modifications in this experiment. Now, अच्छा ठीक है, मैं तुम बहुत देर से कुछ बोलना चाह रहे हो प्रथमेश. ओके, बोलो.
सर असल में ग्रीन ग्लो ऐसी मतलब हमारे अखिल देव सर ने बोला था कि ग्रीन ग्लो क्योंकि उन्होंने एनोड एंड में कुछ जिंक सल्फेट एक फ्लोरोसेंट मटेरियल रखा था इसीलिए हो रहा था. बट असल में ये क्या बिना जिंक सल्फेट के हो रहा था ये ग्रीन ग्लो बिना बिहाइंड द एनोड.
हाँ, so when you coat the glass with certain substances, they help you visualize better.
मतलब ये जो इन लोग का जो ओरिजिनल ऑब्जेक्टिव था मींस टू स्टडी द फ्लो ऑफ इलेक्ट्रिसिटी थ्रू गैस. तो उन्होंने एक जिंक सल्फेट पहले यूज किया था कि
नहीं
अभी मॉडिफिकेशन में यूज होने वाला था.
नहीं, to begin with नहीं. So I'll show you one more video. थोड़ा सा देर वेट करो, I'll show you one more video. इसमें they would have a ऐसे ही कोटेड मटेरियल का शीट बिहाइंड that will help you visualize the glow much better.
Okay.
ठीक है. So to begin with,
zinc sulfate was a modification.
that is something which comes to help visualize things better.
Okay. Thank you, sir.
ठीक है. That is something which helps trace the path in a better manner. मैं बताऊंगा थोड़ी देर में. अभी के लिए let's not focus on that. हाँ, वैक्यूम पंप का यूज होता है एयर को सक आउट करने के लिए ताकि अंदर बहुत ही कम गैस बचे, बहुत ही कम एयर बचे. ठीक है. दैट इज द ऑब्जेक्टिव ऑफ वैक्यूम पंप. हाँ सुमित बोलो, क्या डाउट है? तुम हैंड तो रेज करो अपना, तभी मुझे अनम्यूट का ऑप्शन दिखेगा. हाँ बोलो.
सर उनका ओरिजिनल ऑब्जेक्टिव था कि फ्लो ऑफ इलेक्ट्रिसिटी टू गैस. तो फिर वैक्यूम क्यों किया? उनको तो गैस से करना था ना.
सॉरी,
तो उन्होंने मतलब वैक्यूम क्यों बनाया? उनको तो इलेक्ट्रिसिटी तो थ्रू गैस करना था ना, उनका ऑब्जेक्टिव वो था.
low pressure, at very low pressure they wanted to study this, that how does conduction of electricity happen at gases at low pressure or in gases at low pressure.
Okay.
All right, now after this initial experience, after this initial understanding, as I said, the modifications came in. Okay, and these modifications are also interesting, so let me talk about them one by one. So the first modification was something that they did by putting up an object between the electrodes. Okay, an object was placed between electrodes, and what was found was that उस object का shadow बन गया on the glass wall behind anode. Right, so यहाँ पर let's say ये आपका glass tube था, this was cathode and this was anode. So what was observed after placing the object, ठीक है, कोई एक ऑब्जेक्ट यहाँ पे प्लेस कर दिया तो उसका शैडो इस ग्लास वॉल पर बिहाइंड द एनोड. सो ग्रीन ग्लो हो रहा था ठीक है, but उस green glow में there was this shadow that came in. ठीक है. So what was the conclusion? The conclusion that came was that the glow seems to be because of some rays. ठीक है, some invisible rays, because you can't see the rays in between. The glow is coming because of some rays, and these rays, they are traveling from cathode towards anode. That is why the shadow is appearing on the anode side. ठीक है, so इससे conclusion ये समझ में आया that the green glow is maybe because of some rays traveling from cathode towards anode at high speeds and in straight lines. ठीक है, so let me put that conclusion over here. The conclusion was, this was the modification, then observation was a shadow of the object appeared on the glass wall behind anode. Right, so what made them conclude was that the glow was due to certain rays coming from cathode towards anode, and they were traveling at high speeds and in straight lines. Okay, the rays. So this came out as the first modification. All right, so then they decided to put in another modification, and this time a thin sheet, very thin sheet of metal was placed in between electrodes. Okay, a very thin sheet was placed in between electrodes, and in this case the rays were able to penetrate through. ठीक है, ऐसा नहीं था जैसे यहाँ पर पहले जो ऑब्जेक्ट प्लेस किया था, इट वाज अ थिक ऑब्जेक्ट, ओपेक ऑब्जेक्ट, जिसके थ्रू रेज पास नहीं कर पा रही थी. दिस टाइम a very thin sheet of metal was placed between the electrodes. So what happened was, there was this sheet was unable to prevent the glow. What did it suggest? It suggested that these rays are something which are different from our light rays, normal light rays. Because if we talk about the rays that we encounter in our day-to-day life, the light rays coming from, say, sun or some object emitting light, the light rays weren't able to penetrate through those thin or very thin sheets of metal. The thin sheets of metal were still opaque to them. But these rays, they were something different, because they were able to penetrate through the thin sheet of metal. So what was concluded was that unlike regular light rays, these rays were able to penetrate through thin sheet of metal. So it was something different, something interesting. So then they decided to do another modification, and the modification was that a light paddle wheel was placed in the path of these rays. ठीक है, कैसा लाइट सा आप मान लो एक पैडल व्हील था which was free to rotate about a hinge, and that was placed in the path of these rays. And what was observed was that this light paddle wheel underwent mechanical motion. ठीक है, ये जो पैडल व्हील था, this actually showed mechanical motion, rotate होने लगा. Now at that point in time it was thought about that maybe that the conclusion that was drawn from this was that maybe these rays are made up of certain particles, और उनका नाम दे दिया कैथोड रे पार्टिकल्स. ठीक है, बिकॉज कैथोड से एमर्ज हो रहे हैं. And maybe these particles, when they are striking this paddle wheel, they are imparting energy, they are transferring momentum, and because of that a force is exerted which results in this mechanical motion of the paddle wheel. Now later, actually it was something discovered much later, not at that point in time. Later is what it was discovered that the rotation or the mechanical motion was not because of the momentum transfer, it was because of heating effects that happened inside. So the particles struck on one side of the plate, raising the temperature on that side, whereas the other side was cooler, and because of that temperature gradient there was this motion that was induced. ठीक है, बट वो बात की स्टडी की बात है. ठीक है, उस जमाने में तो यही सोचा था कि चलो कुछ पार्टिकल्स होंगे जिनकी वजह से ये हुआ है. ठीक है, बिकॉज अदरवाइज वी डोंट सी normal light striking even a light feather and like inducing any mechanical motion on it. So the next modification was done, and this time the modification that was done was that an external electrical field, ठीक है, or you could have taken magnetic field also, magnet भी use करा, an external electrical or magnetic field was applied across the path of these rays. Right, so ये हमारा ग्लास ट्यूब था, एंड इस ग्लास ट्यूब में से लेट्स से लेफ्ट हैंड साइड कैथोड है एंड राइट हैंड साइड एनोड है. राइट, दीज रेज वर कमिंग, एंड यहाँ पर एक एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाई कर दिया. ठीक है, लेट मी ड्रॉ इट विद सम अदर इंक. ठीक है, एक पॉजिटिव प्लेट और एक से नेगेटिव प्लेट. ठीक है, एक्सटर्नल फील्ड ऐसे अप्लाई कर दिया, इलेक्ट्रिक फील्ड अप्लाई कर दिया. नाउ व्हाट हैपेंड इज बिकॉज ऑफ दिस, पहले मान लो कोई एक ऑब्जेक्ट यहाँ पर रखा था जिसका शैडो पीछे बन रहा था. अब व्हाट हैपेंड वाज दैट द शैडो got shifted slightly. Okay, and the shadow got shifted towards the positive plate. Okay, shift in shadow was observed. So what it concluded was that maybe because of this field, the particles that make up these rays are getting deflected, and the direction of the deflection suggested, ठीक है, because ये rays positive जो external electric field था उसके positive plate की तरफ shift हो रहे थे, तो direction of deflection suggested that cathode ray particles are negatively charged. They are actually attracted towards the positively charged plate, and that led to this deflection of the shadow. Now, based on these modifications, ठीक है, अभी देखो इलेक्ट्रॉन वर्ड कॉइन नहीं हुआ है, देयर हैज बीन नो मेंशन ऑफ द वर्ड इलेक्ट्रॉन, एंड उस टाइम पर हुआ भी नहीं था, मतलब दिस वाज समवेयर अराउंड 1850s when these modifications were being done. ठीक है, and what was concluded was that based on this setup we have discovered something new. Now they gave the name to this something new as cathode rays, and they concluded some observations or some characteristics about these cathode rays, which were as follows: that these rays, when they strike the glass wall, they create a certain kind of a glow. They travel at high speeds, they travel in straight line, and if you place an object in their path, they make a shadow of it on some background. They can penetrate through thin sheet of metal, so they are not like the normal rays, they are something different. And they are made up of certain particles, because these particles, when they strike some object in their path, some light object, they can cause mechanical motion. And based on this modification of the externally applied electric and magnetic field, they also concluded that these particles which make up these cathode rays, ठीक है, they are negatively charged. ठीक है, and उनका नाम भी क्या रखा गया? Cathode ray particles. ठीक है, अभी तक इलेक्ट्रॉन वर्ड कॉइन ही नहीं हुआ. It was much later in 1880s or something when electron term was coined. ठीक है, this is credited to a scientist called G.J. Stoney, who kind of correlated what Faraday had postulated long back. ठीक है, Faraday ने बहुत पहले postulate किया था that electricity is made up of something tiny negative particles, but he was never able to isolate them. Okay, he was never able to isolate them and bring them to as a live visualization. So what G.J. Stoney said that these cathode ray particles are actually those small tiny negatively charged particles that make up electricity, and from there he derived this word called electrons. Okay, so the term electron was given to cathode ray particles. And interestingly, abhi bhi, it was not concluded that electron is a subatomic particle or something like that. It took many years and more modifications and rigorous set of experiments that gave electron the status of a subatomic particle, that it is something which is present inside an atom. So this is something that happened around 1890s. ठीक है, 1890s में J.J. Thomson, J.J. Thomson is to be credited with giving electron its subatomic status. So what J.J. Thomson did was J.J. Thomson applied mass spectrometry technique to CRT experiment. ठीक है, now what is mass spectrometry technique? This is an experiment based technique which tries to get information about very small charged particles. ठीक है, मतलब for example that you came up with this particle, जो cathode ray tube particle है, इसको आपको और डेप्थ में स्टडी करना है. ठीक है, imagine you yourself in that situation where I am asking you to study this cathode ray particle. Now it is so tiny that you can't even see it. What you can see it are its effects. You can see that yes, once it strikes the glass walls, there is a glow that is created. Once it strikes a light paddle wheel, there is this motion that is produced. Once there is this electric field that is applied across it, we can see some deflection happening. ठीक है, but we can't really see the particle. ठीक है, ऐसा नहीं है ना कि मैं हाथ से उठा के उसको isolate करके study कर सकता हूँ anything. So there were these techniques that were developed by scientists at that point in time to study things at such small scale. And one such technique that was developed was called mass spectrometry technique that was given by J.J. Thomson. Now, what happens inside is a matter of again study of electricity and magnetism. ठीक है, what happens is that इलेक्ट्रिक फील्ड, मान लो एक पार्टिकल आ रहा है, चार्ज पार्टिकल आ रहा है. ठीक है, मैं जस्ट एक ऊपर से कर्सरी आइडिया दे रहा हूँ. दिस इज नॉट समथिंग व्हिच इज पार्ट ऑफ आवर सिलेबस. नोबडी इज गोइंग टू आस्क यू क्वेश्चंस ऑन मास स्पेक्ट्रोमेट्री, क्या था, कैसे करते हैं. आई एम जस्ट गिविंग यू फॉर द सेक ऑफ नॉलेज है. एक चार्ज पार्टिकल ट्रैवल कर रहा है. नाउ इफ यू अप्लाई एन इलेक्ट्रिक फील्ड अक्रॉस इट, ठीक है, it is going to deflect. It is going to deflect either up or down depending upon how the electric field is applied. And simultaneously, let's say if you apply a magnetic field, ठीक है, ऐसे B से represent करते हैं. If you apply a magnetic field, then the magnetic field is applied in such a manner that it counteracts the electric field and makes the trajectory of the particle straight again. And by changing the electric field and magnetic field, you can understand how both electric and magnetic field can balance their deflections. And what you get based on the mathematical equations when you kind of equate the effect of electric field to the effect of magnetic field such that there is no deflection in the path, the particle goes straight through, you get charge by mass ratio Q by M of the particle. ठीक है, you will not get charge, you will not get mass, but you will get charge upon mass का value. So this was something which was at that point in time a very path breaking, simplistic yet path breaking technique that helped us to study these tiny charged particles. So what J.J. Thomson did was J.J. Thomson applied this technique onto the cathode ray tube particles. Now, as a result, ठीक है, यहाँ पे मैं सीधे इसके नीचे लिख देता हूँ. as a result, Q by M, that is charge upon mass ratio of electrons, or you can say cathode ray particles, was calculated, or you can say was found to be 1.76 into 10 raised to the power of 11 coulomb per kg. ये आपको याद रखना है. This is the value that came for the electrons. Now, what was interesting that happened along with this was that this value was found to be 1.76 into 10 raised to the power of 11 coulomb per kg, a constant value irrespective of the type of gas or material of electrode. So inside the tube, you take hydrogen gas, you take nitrogen gas, you take helium gas, doesn't matter. You take iron as the metal or nickel as the metal inside, chromium as a metal, doesn't matter. Irrespective of the raw material used inside that tube, this value came out to be constant. And that is what led, that is what made J.J. Thomson conclude that this electron or this cathode ray tube particle is something fundamental. It is something which is present inside the atom of all the elements that are being used. And that is where electron got its status of subatomic particle. Now, हो सकता है कि अभी आपके दिमाग में और डाउट्स आ रहे हो that what exactly happened or how can you relate with, you know, gas inside and electrode ka material inside with these cathode ray tube particles or these electrons. So let's talk about the same experiment that we just saw in a little bit more detail, that exactly how these cathode rays are produced. Okay. In fact, I would be quite interested to know an explanation from the students who have already studied this part. Okay. Let me know any information that you have, that what exactly happens inside the cathode ray tube. मतलब ऐसा क्या हो जाता है कि इस सेटअप के अंदर, ये जो सेटअप है इसके अंदर मैंने ऐसे हाई पोटेंशियल डिफरेंस अप्लाई करा एंड उससे ये रेज एमिट होने लग गए. रेज से ग्रीन ग्लो समझ में आया, बट रेज कैसे एमिट हो रहे हैं, कहाँ से एमिट हो रहे हैं, क्यों एमिट हो रहे हैं, एनी आइडिया बिहाइंड इट? एनीवन वांट टू टेक अ शॉट? हाँ हर्ष, ग्रेट. सो आप अपना हाथ रेज करो so that I can unmute you. All right, go ahead.
Yes, sir.
Yeah, we were able to hear you. Go ahead.
Okay. So, there's a zinc sulfide coating as an anode. So it has a property like it is a fluorescent material. So when so the cathode rays when strikes it at a high speed, its kinetic energy gets changed. The zinc sulfide, it uses its kinetic energy to produce light.
नो बट आई एम आस्किंग कि कैथोड रे कहाँ से आया? आपने मुझे ये समझाया कि जो ग्रीन ग्लो है वो कैसे हो रहा है, मैं वो नहीं पूछ रहा हूँ, मैं उसके पहले का क्वेश्चन पूछ रहा हूँ कि ये रे आया कहाँ से?
So
all right, so Shreyansh. All right, I'll give Shreyansh a chance. हाँ
Yeah, sir, so what exactly happens is due to very high potential difference, which is approximately equal to 10,000 volts, the electrons at the cathode, they get emitted, they gain kinetic energy, and they hit the other gas particles, the gas molecules, due to which the gas molecules are they are ion. They split to single atoms, after which the gas particles are ionized, and other electrons also are emitted from the gas particles, which totally composes the bulk of the cathode ray particles and forms the cathode rays. I think that is it.
हाँ हाँ मतलब सो ओके अच्छा एक्सप्लेनेशन दिया आपने. आई विल नॉट से इट्स सुपर आर्टिकुलेट बट हाँ. Okay, Sanika also wants to give an explanation. Sanika, I'll give you a chance.
Yes, sir. Sir, you said a case. Am I audible?
Yeah.
So you said a case when the rays were deflected by electrical and magnetic fields.
Uh-huh.
So this shows that the rays which are deflected are definitely charged particles, and maybe the direction of deflection shows that they are negatively charged, and so they are cathode rays.
Yeah, but I'm asking about the origin. Where did these rays come from? Like, so you are saying that these rays came from the material of cathode.
Because of the flow of electrons, and yes, like electricity is flowing through the setup, right? So
हाँ ठीक है. थोड़ा सा मैं इसमें और डिटेल्स ऐड करना चाहूँगा. ऑल राइट. प्रथमेश, अनम्यूट कर रहा हूँ तुम्हें.
सर मुझे लगता है कि वो because of the high potential difference, I think that the atoms in the cathode metal must be getting detached, and they must be gaining some kinetic energy because they are negatively charged. They must be flowing towards the anode. I think they are the detached atoms from the cathode.
हाँ, right. So let me put some more perspective into this. So आप लोगों के पास खैर आज की तारीख में तो सबके घर में प्लाज्मा टीवी होता है या फिर एलसीडी या एलईडी टीवी रहता है. ठीक है. बट पुराने जमाने में देयर यूज्ड टू बी दीज सीआरटीज. ठीक है. जो कलर्ड टीवी होते थे, मोटे मोटे बल्क में जो रहते थे, those were actually based on the same principle. ठीक है. In fact, in the new vacuum tubes, ठीक है, the new vacuum tubes that we have, उसमें भी एक्सपेरिमेंट रिपीट करा जाता है. किस तरीके से? ये जो कैथोड का मटेरियल होता है, ठीक है, कैथोड के मटेरियल को हीट करते हैं. ठीक है. एंड हीट करने से कैथोड के जो मटेरियल के जो एटम्स होते हैं, दे इजेक्ट इलेक्ट्रॉन्स. ठीक है. एंड what you do is because you have applied a high potential difference, ठीक है, तो इन इलेक्ट्रॉन्स के ऊपर एक फोर्स लगता है एंड काफी स्ट्रॉन्ग फोर्स लगता है which drives them towards the oppositely charged plate, the positively charged plate. That is what makes up the cathode rays. But this is the new version. This is thermionic emission based CRT. इसमें क्या होता है? अंदर गैस की रिक्वायरमेंट ही नहीं है, अंदर सुपर हाई वैक्यूम है. There is no requirement of gas. Now, what happened in the original experiment? ठीक है, we didn't have a super high vacuum. What happened in the original experiment was that ये जो अंदर गैस प्रेजेंट होती है, ठीक है, अंदर जो गैस प्रेजेंट होती है, in any given sample of gas, in any given sample of air also, naturally there exist some ions. ठीक है. ये जो गैस अंदर एक कंटेनर के अंदर गैस रखा होगा, ठीक है, this gas would have been exposed to radiations, and these radiations would have made the electrons come out of the gas atoms, making gas ions, positively charged gas ions. ठीक है, बहुत ही small fraction, very very tiny fraction in any naturally occurring sample. Now what happens is that यहाँ पर इस ट्यूब के अंदर भी जो गैस रखा हुआ है, इस ट्यूब के अंदर भी जो गैस रखा हुआ है, उस गैस के अंदर भी naturally there are some ions that are present inside. ठीक है, some positively charged ions, very very tiny fraction, but they are present. Now what happens is, once you apply this high potential difference, these positive ions, they travel at very high speed towards the negatively charged plate. Okay, they travel at extremely high speeds because of the high potential difference that you have applied. Now when they travel in their path, they come across other gaseous atoms. तो starting में भले let's say बहुत कम number of ions थे, but these ions, when they hit the other atoms, they transfer that energy and eject electrons out of those atoms as well. So ये एक आयन आया, इसने एक एटम को हिट करा और इसमें से इलेक्ट्रॉन इजेक्ट हो गया और ये भी एक आयन बन गया. तो it all starts to pile up. It's like a chain reaction. बहुत ही कम amount of ion से बहुत ही जल्दी you get a lot of positive gaseous ions, and when these gaseous ions, they strike the cathode material also. ठीक है, कैथोड के मटेरियल पे भी हाई स्पीड में आयंस आके टकराते हैं, तो इलेक्ट्रॉन्स इनमें से इजेक्ट होता है. ठीक है, इनके एटम से भी इलेक्ट्रॉन्स इजेक्ट होता है. सो जो कैथोड के मटेरियल से इलेक्ट्रॉन्स आ रहे हैं, एज वेल एज जो गैस के पार्टिकल्स से जो इलेक्ट्रॉन्स आ रहे हैं, they collectively make up what we call as cathode rays. So that is what was happening in the experiment, the YouTube video that I just showed you. ठीक है, यहाँ पर observe करना. I will take you through that video again. ठीक है, I will pause the frame appropriately. So ये जनरेटर का सेटअप है. ठीक है, this is actually जनरेटर का सेटअप पीछे है. ये जो स्टार्टिंग में दिखाया, let me take, this is right now, this is the vacuum pump. ठीक है, ये पंप जो है ये ग्लास ट्यूब से कनेक्टेड है और ये पंप एयर को सक आउट करने के लिए स्टार्ट करा जाएगा. ठीक है, ये ग्लास ट्यूब है एंड पीछे जो ये ब्लैक ब्लैक सा दिखा रहे हैं, ठीक है, अभी तो एक है ग्लास ट्यूब दिखा रहे हैं. दिस इज योर ग्लास ट्यूब. नाउ एट द बैक, दिस इज द जनरेटर. दिस इज व्हाट इज जनरेटिंग द हाई पोटेंशियल डिफरेंस. ठीक है, सो नाउ दे विल स्विच ऑफ द रूम का लाइट एंड दे विल इग्नाइट द जनरेटर. दिस इज द जनरेटर वर्किंग. ठीक है, दिस इज द जनरेटर वर्किंग. इट्स अ डीसी जनरेटर. And now this is the cathode ray tube in front of you. Now initially this pink glow that you see is because of the gaseous ions. ठीक है, these are the gaseous ions जिनकी वजह से ये पिंक ग्लो आ रहा है. अभी थोड़ी देर बाद ही मैं आपको इनका नाम बताऊंगा. इनको एनोड रेज हम बोलते हैं. ठीक है, now the pump is working simultaneously. The pump is trying to suck out the air as much as possible. Okay, now as you can see the pump is trying to suck out the air. ये पंप के यहाँ पर अभी आपको ग्लो दिख रहा है, काफी सारा ग्लो हो रहा है अब. ठीक है, so the pump is trying to suck out the air, the gas that is present inside, and after a point when there is enough vacuum, ठीक है, the electrons get the opportunity to reach the other side. ठीक है, इसके पहले कैसा हो रहा था? इसके पहले जो ट्यूब था that was crowded by the gas ions. It was crowded by the gas ions, and because of which the electrons were not able to reach the other side. But now, because the gas has been adequately removed, the electrons can now reach the other side, and you can see that there is a green glow. ठीक है? In fact, let me show you one more picture. Yeah, this is simultaneously showing you both anode rays and cathode rays. ठीक है, यहाँ पर ये जो ऊपर पिंक ग्लो आपको दिख रहा है ना, ये एनोड रेज का है. These are the positively charged. ये this is your anode, sorry, this is your cathode. ठीक है, and this side is your anode. तो कैथोड के पीछे, इसमें कैथोड में क्या कर दिया? कैथोड में ऐसे they have created holes. ठीक है, they have modified the experiment, and the cathode plate has holes, so the anode rays can pass through, and they can be seen clearly behind the cathode. And what you can see here, the green glow, which is not so green in this image, this green glow is caused by cathode rays. ठीक है, so this is trying to help you understand what exactly happened in this experiment that gave rise to the negatively charged particles or these cathode rays. ठीक है, अच्छा, आई एम श्योर आपको अब कुछ डाउट्स रहेंगे, so I'll address them one by one. So okay, let me start. Just a second. There is Anu ka doubt, how come positive ions are present in the tube? So Anu, that is something that I said, because of that gas sample naturally has. ठीक है, कैसा होगा? ये आपका एक gas sample रखा हुआ होगा, and radiations आए होंगे. Sometimes there can be X-rays or UV rays, which are high energy radiations that can eject electrons out of atoms. ठीक है, ये मैं आपको बताऊंगा थोड़े टाइम बाद जब हम लोग बोर्स मॉडल पढ़ेंगे. आप लोगों ने शायद जूनियर क्लासेस में पढ़ा होगा, इस वजह से आपको शायद थोड़ा आइडिया होगा दैट हाई एनर्जी रेडिएशंस कैन एक्चुअली इजेक्ट इलेक्ट्रॉन्स. इनको आयोनाइजिंग रेडिएशंस इसीलिए बोलते हैं. तो इन अ नेचुरली अकरिंग सैंपल देयर कैन बी some exposure to such rays which can cause some atoms to eject electrons and form positively charged ions. ठीक है, all right, then I think it will be better if you raise your hand. मेरे को चैट में थोड़ा सा स्क्रॉल करने में प्रॉब्लम आ रहा है, so you raise your hand and ask the doubt. I think I will पहले किसने रेज किया हुआ है? श्रेयांश ने. हाँ बोलो. नहीं सॉरी, मैंने हाँ बोलो.
So basically the cathode emits the electrons by itself because of the high PD, or it happens after only the electrons are emitted from the gas molecules because of exposure to X-rays or anything else.
हाँ, so देखो कैथोड जो है ना, कैथोड से अपने आप इलेक्ट्रॉन्स निकलने का चांस बहुत कम है. ठीक है, either you heat this up, जैसे मैंने आपको बताया थर्मोनिक एमिशन बेस्ड ट्यूब्स यूज करो. ठीक है, either you heat up the material of cathode, or when these electrons or when these positively charged ions they strike the material, that also results in ejection of electrons. ठीक है, ऐसे इंडिविजुअली भी, मतलब जैसे आप लोग अगर एक प्लेट रखा हुआ है, ठीक है, तो उस पे अगर आप मेटल प्लेट पे भी रेडिएशंस डालते हो तो भी इलेक्ट्रॉन्स इजेक्ट होते हैं, ठीक है, बट दे आर वेरी लेस इन नंबर. So you will have to either you will have to provide some form of energy for the electrons to come out. ठीक है, that is the underlying principle. Either you provide that energy in form of heat, either that you provide that energy in form of radiation, or either you provide that energy by mechanical kinetic energy of some particles hitting the metal atoms, but you will have to provide some energy for the electrons to come out. Once those electrons come out, then they will travel at very high speeds because of the potential difference that you have applied. All right, then there is जिसका हो गया आप अपना हाथ लोअर कर लो. Okay, so शेखर, हाँ आप बोलो.
Sir, can cathode rays form other colors other than green?
सी जो कलर आता है ना वो रेज की वजह से नहीं आता. सो कल को अगर मैं आपको क्वेश्चन पूछूं व्हाट इज द कलर ऑफ कैथोड रेज, योर आंसर शुड बी इनविजिबल. कैथोड रेज हमें दिखते नहीं है. कैथोड रेज जब किसी मटेरियल पे स्ट्राइक करते हैं तब कलर आता है, ठीक है. अब वो कलर चेंज भी हो सकता है डिपेंडिंग अपॉन द मटेरियल जिस पर वो स्ट्राइक कर रहे हैं.
Yes, thank you sir.
ठीक है, ओके रावी आप पूछो.
सर ये जो एक्सपेरिमेंट हुआ ये एकदम ऐसा ओल्डन टाइम्स में था जब गैस रिक्वायर्ड था, बट यू सेड कि अभी जो मॉडर्न एक्सपेरिमेंट्स हुए, जो एप्लीकेशंस हुए इनकी, उसमें गैस रिक्वायर्ड नहीं है. तो व्हाट सॉर्ट ऑफ एनर्जी इज यूज्ड टू फॉर दैट so that the electrons will come out of the atoms?
Heat, thermionic emissions.
Okay.
We heat the material of cathode.
Okay sir.
Okay, Sumit.
हेलो सर.
हाँ बोलो.
सर सो बेसिकली जो कैथोड जो एक ट्यूब है इसके अंदर एक गैस है एंड ड्यू टू लाइक एटमॉस्फेरिक प्रेशर एंड पोटेंशियल एनर्जी गैस से इलेक्ट्रॉन सेपरेट हो रहा है, राइट, एंड दैट फॉर्म्स द कैथोड रेज.
दैट आल्सो. सो जो इलेक्ट्रॉन्स हैं कैथोड रे के, some of those electrons come from the gas that is present inside, some of the electrons come from the material of cathode. जो metal plate लगाया होगा ना कैथोड पर, वहां से दोनों से आता है.
Okay. And so what kind of changes we'll find if we change the gas?
So that is what the interesting observation was by J.J. Thomson. That is what he said, that if we change the gas or we change the material of electrode, the fundamental property of these particles, that is their charge by mass ratio, is not changing. That means this is something which is present inside the atom, okay, and it is present inside all the atoms. So it is even more fundamental than an atom. It is, then it was given a status of a subatomic particle.
Okay sir. Sir, like ऐसे theoretical based questions आते हैं क्या जेईई में?
Well, not exactly, but they help build up towards a larger set of questions. ऐसे स्टैंड अलोन मैनर में नहीं आता है. हाँ ऋग्वेद पूछो.
हाँ सर, तो ये इलेक्ट्रॉन्स जो है वे एनोड की तरफ जा रहे हैं क्योंकि एनोड अट्रैक्ट कर रहा है इनको, तो फिर सभी इलेक्ट्रॉन एनोड पे डिपॉजिट क्यों नहीं हो रहा?
ओके, सो ठीक है, पार्शियली you are right that anode attract कर रहा है, but it is not the anode which is like just attracting it, जिसकी वजह से ये electrons इधर जा रहे हैं. That's a very simplistic way to put it. Rather, I will in fact tell you that there are modifications. So जैसे आप देखोगे थॉमसन के मॉडिफिकेशन में कैसा था, थॉमसन का अगर आप सेटअप देखोगे ना, थॉमसन का सेटअप कुछ इनफैक्ट थॉमसन के पहले भी जो साइंटिस्ट थे उनका एक्सपेरिमेंटल सेटअप भी थोड़ा सा चेंज था. ये कैथोड है एंड यहाँ पर एनोड है, ठीक है. इस तरीके से सेटअप है and the thing is that once electrons are ejected, ठीक है, they actually go in straight lines. वो पूरा ऐसे एक बर्स्ट होता है इलेक्ट्रॉन्स का, ठीक है, बट ऐसा नहीं होगा कि अरे एनोड यहाँ पर है तो ये सब के सब ऐसे एनोड की तरफ मुड़ गए. They are actually traveling at very very high speed and high energies. जो इलेक्ट्रिक फील्ड लगा है यहाँ पर, जो ये आपने 10,000 वोल्ट का इलेक्ट्रिक फील्ड लगा है, दैट इज मेकिंग दीज इलेक्ट्रॉन्स गो extremely fast in one direction. ठीक है.
ओके सर.
हाँ, right. So yeah, I think हाँ अभी बहुत हो गया डाउट्स भाई, अभी रुक जाओ, घर जाना है अब, तुम लोगों को सोना भी है. ठीक है, दैट इज व्हाट हैपेंस, दिस इज व्हाट हैपेंस टिपिकली, एंड आई लाइक दिस इंटरेक्शन इन द बिगिनिंग इटसेल्फ. थोड़ा बहुत इंटरेस्टिंग पार्ट है इस चैप्टर के साथ में, देयर इज अ लॉट ऑफ हिस्ट्री अटैच्ड टू इट. ठीक है, वैसे अभी इलेक्ट्रॉन की कहानी खत्म नहीं हुई है, अभी इलेक्ट्रॉन पे हम लोग थोड़ा सा और डिस्कशन करेंगे through an experiment called as Millikan's experiment, but yeah, that will be something in the next class only. So what I would request is जिन लोगों को doubts है वो रुक सकते हैं, they can continue asking the doubts. I will take up 10-15 more minutes to answer all your queries, and the remaining students can drop if you don't have any doubts, because class ka time is close to finish. ठीक है, right. So coming लक्षिता, आप क्योंकि बोल रहे हो आपका माइक नहीं काम कर रहा है, तो कैन यू टाइप योर डाउट अक्रॉस. इन द मीन टाइम श्रेयांश तुम बोलो. अरे नहीं सॉरी, हाँ बोलो.
सर तो मतलब बेसिकली कोई ना कोई काइंड ऑफ एनर्जी चाहिए इलेक्ट्रॉन्स को निकलवाने के लिए.
हाँ
सर विदाउट उस सर, क्योंकि इसके पहले जो हमारे सर थे उन्होंने तो कहा था कि वो खुद ही निकल आते हैं.
नहीं ऐसे मतलब बिकॉज आपने कोई ना कोई एनर्जी प्रोवाइड करोगे किसी ना किसी फॉर्म में, तो ये इलेक्ट्रॉन इजेक्ट होंगे.
सर मतलब विदाउट पोटेंशियल डिफरेंस, मतलब पोटेंशियल डिफरेंस से कुछ फर्क नहीं पड़ेगा जब तक वो निकलेंगे नहीं.
Potential difference is going to help take those electrons
to anode,
towards anode at a very high speed.
Okay sir.
ठीक है. हाँ, so लक्षिता का डाउट है, there are no negative ions naturally present in gas sample. Well, negative ions हो सकते हैं, ठीक है, but उनका they are anyways not going to affect the experimental observation, because the quantity will be very less. मतलब the thing is that you have gaseous atom, and the reason why they become ionized is because the electrons get ejected. So what is left behind is a positively charged ions. ठीक है, जनरली ऐसा नहीं होता कि गैस आयंस जो गैस एटम्स होंगे, ठीक है, गैस एटम इलेक्ट्रॉन को अपने ऊपर अट्रैक्ट नहीं करेंगे. ऐसा नहीं होगा कि O2 गैस रखे रखे O2 माइनस आयंस बना लेगा. ठीक है, दैट इज नॉट समथिंग which it will do by itself. All right, then आयुर का क्या डाउट है सर? इन द एक्सपेरिमेंट ओनली इलेक्ट्रॉन्स आर एमिटेड, और आर देयर एनी अदर पार्टिकल्स, एलिमेंट्री पार्टिकल्स? हो सकते हैं आयुर, डेफिनेटली हो सकते हैं, मतलब और भी एलिमेंट्री पार्टिकल्स उस टाइम पे डिटेक्ट नहीं होंगे. ठीक है. देन ईशा का डाउट है, सर व्हाई आर द एनोड रेज सप्रेस्ड बाय कैथोड रेज? नहीं ऐसा तो नहीं हो रहा ईशा. both the rays are going to coexist simultaneously. मैंने आपको ये फोटो दिखाया था ना, this photo is what is helping you see and highlight that cathode rays and anode rays both are there. ऐसा नहीं है कि एक बार में एक ही रे रहती है, ठीक है, या फिर एक रे दूसरी रे को सप्रेस कर रही है. वो जो वीडियो अपन ने देखा था उसमें, हाँ, दैट स्टार्टिंग में क्योंकि गैस का अमाउंट ज्यादा है, द इलेक्ट्रॉन्स weren't able to reach the other side because the gas atoms or molecules were too many. ठीक है, जब वैक्यूम क्रिएट करा गया, जब गैस को पंप आउट किया गया, then these cathode rays or these electrons got the opportunity of reaching the other side, striking the glass wall and creating a green glow. All right, any other doubts? All right, great. Then I think we can close the lecture for the day. ठीक है, अभी I don't know next week का आपका schedule क्या है, कैसा है, but once I get it, I will let you know on which days mole concept will go on and on which days atomic will be continued. ठीक है,
हेलो
I'll let you
सर.
know. हाँ बोलो.
सर मेरा वो न्यूट्रॉन वाला वो डाउट था.
हाँ हाँ हाँ, क्या डाउट था तुम्हारा?
मतलब सर अगर एटम्स में इलेक्ट्रॉन्स और प्रोटॉन सेम होते हैं तो तो एटम न्यूट्रल हो गया ना, तो उसमें न्यूट्रॉन का काम क्या है?
न्यूट्रॉन का काम बहुत इंटरेस्टिंग और बहुत इंपॉर्टेंट होता है. तो आपका ये जो डाउट है ना, दिस डाउट एक्चुअली लीड्स टू न्यूक्लियर साइंस.
ओके.
जैसे आपको डाउट आएगा कि प्रोटॉन न्यूक्लियस के अंदर अगर मान लो सिर्फ और सिर्फ प्रोटॉन होते हैं, तो वो तो सब पॉजिटिवली चार्ज है, वो तो आपस में रिपेल करके एक दूसरे से दूर हो जाएंगे.
हाँ.
बट वो फिर साथ में कैसे रहते हैं न्यूक्लियस के अंदर?
यस सर.
So that is what your doubt will lead to. It is going to lead to a new or a different kind of force which was not known by the scientists at that point in time, got later discovered, called as nuclear force.
यस सर.
है ना, तो वो इस पर्टिकुलर चैप्टर का डिस्कशन नहीं है, वो डेफिनेटली आप 12th क्लास में डिस्कस करोगे. 12th क्लास में जो मॉडर्न फिजिक्स चैप्टर आएगा ना, उसमें न्यूक्लियर फोर्स के बारे में थोड़ा बात करा जाएगा.
ओके सर. थैंक यू सर.
हाँ, ग्रेट. ओके. हाँ लक्षिता, क्या है आपका डाउट? सर यू सेड इलेक्ट्रॉन्स कुड क्रॉस मेटल फॉइल बट इन केस ऑफ गोल्ड फॉइल एक्सपेरिमेंट दे डिफ्लेक्ट. अक्षिता, हम बात करेंगे इस बारे में, अभी रुक जाओ. आई थिंक गोल्ड फॉइल एक्सपेरिमेंट का नॉलेज आपको शायद पूरा नहीं है. उसमें अल्फा पार्टिकल्स यूज किए गए थे एंड उसमें जो डिफ्लेक्शंस हुए थे उनके बारे में मैं बात करूंगा अलग से. मे बी योर डाउट विल गेट क्लियर एट दैट पॉइंट इन टाइम. इसको अभी होल्ड पे रख लो. All right, good. So I think let's close the session for the day. We'll meet next time. Till then, take care, guys.